This is Geometry, Unit 6, Day 3. We're going to use proportions to solve geometry problems. If A and B are two numbers or quantities, then the ratio A to B can be written with a colon, or it can be written as a fraction. An equation that states that two ratios are equal is a proportion. Ratios are pretty much a fraction. So if you have an equation that states two fractions are equal, then it's a proportion. These are examples of ratios, not proportions, because there's no equal sign. We're going to reduce or simplify these ratios. To simplify the ratios, you need to have the units in the same measure. Here they're both centimeters, so I'm looking for a number that goes into them both. 4 can be divided into both of these numbers. 4 goes into 76 19 times, and 4 goes into 8 2 times. For the second one, we have our units different. We need to make the units the same. It doesn't matter if we make them both inches or if we make them both feet. I like to make my numbers smaller rather than bigger, so I'm going to suggest to convert 24 inches. We all know that 12 inches is in a foot, so two groups of 12 makes 2 feet. So now we're going to divide by 2, and we'll get 2 feet to 1 foot. We reduced it. 4 meters to 18 meters. The only number that can go into both of those is 2. So we get 2m to 9m. We reduced that ratio. Yards to feet. Well, a yard is bigger than a foot. There are 3 feet in every yard. So if we said 33 yards, if this is 9 feet, how many yards is 9 feet? We have 3 yards. So now we can divide this by 3. So we get 11 yards to 1 yard. On this second example, it's very common to see in standardized testing. It'll definitely be on an exam or on the test. The measure of the angles of triangle BCD are in the extended ratio 2, 3, 4. That means that these 3 angles are either the numbers 2 degrees, 3 degrees, or 4 degrees, or there's some multiple of that, like 4, 6, and 8, 20, 30, and 40, 200, 300, 400. They are some multiple of 2, 3, and 4. So, one thing we know for sure is that the measure of angle B plus the measure of angle C and D add up to equal 180 because it's a triangle. It adds up to 180. Well, since B is first and then C and D, we'll say that B is angle 2. So 2 times something makes up angle B, 3 times something makes up angle C, and 4 times something makes up angle D. So together that adds up to 9x, and we divide by 9 to get 20. Now 20 is not one of the angle measures. The measure of angle B is 2 times 20. angle C is 3 times 20. And D is 4 times 20. Together, those all add up to 180 degrees. 20 is the only multiple that could have worked together to be multiplied to 2, 3, 4 to make 180. We have a perimeter of a rectangle. The perimeter of this rectangle is 20 feet, and the ratio of the length to the width. The length, they're saying, relates to the 5, and the width relates to the 2. So I know I have a rectangle with width and length. Now, perimeter it talks about, so we have 2 widths and 2 lengths. The perimeter is going to be 21. So we know that the perimeter equals length plus width plus length plus width. The perimeter is 21. The length is 5. It's 5 times something, so it's 5x. The width is 2 times something, and then 5 times something and 2 times something. It's just not 5 and 2. It's 5 times. It's a ratio, so it's reduced all the way down. So this adds together to be 10 and 4, so it's 14x. We divide by the 14. So 7 goes into each of these, 3 and 2. So we get 3 halves. That's what x is. That's the common multiple that is making up the 21 using the ratio of 5 to 2. So the length is equal to 5 times 3 over 2. So that's 15 over 2, which is 7.5. The width is 2 times 3 halves. That makes 6 halves, which is 3. So the length is 7.5 feet, and the width is 3 feet. Together, those would make 10.5 and 10.5, which makes 21, the perimeter all the way around. The cross product property. You probably have done this many times in the past. Cross product means that you are going to multiply crisscross through this through this proportion. I would suggest for you to physically draw in the 2 circles showing what you are multiplying. So that means we're going to multiply the A and the D and the B and C. So to solve a proportion, we're going to multiply 3 times 16 and 4 times x. That makes 48. We divide by 4. 4 goes into 4 once, 4 goes into 8 twice. So x would have to be 12. Another way you could look at it is 4 times what makes 16? 4 times 4 makes 16. So you know 3 times 4 has to make 12. It's a good way to test it, but it's also an appropriate way to solve for it. But I definitely like to have you show your work for cross multiplying. we have 8 times 5 and 2 times y. So 8 times 5 is 40. 2 times y, divide by the 2, y equals 20. You could look here that 2 times something makes 8. 2 times 4 makes 8. So let's multiply the 5 by that 4. 5 times 4 is 20. A good way to check your work. Now this proportion is a little bit different. It has these two parts. But when we multiply, you still are going to cross multiply for all your proportions. So it's 9 times x minus 3 and 3 times 2x. You'll distribute move your like terms together. Since you're going to the opposite side of the equal sign, you need to be sure to do the opposite operation. So this is a positive 9, so I have to subtract 9. Don't forget you still have a minus 27 or a negative 27. When you divide by 3, we figure out that x equals 9. You know that 9 is going to be the correct answer because when you plug it back into the problem, 9 minus 3 gives you 6. Divided by 3 gives you an answer of 2. Plug the 9 in for the other ratio. 2 times 9 is 18. Divided by 9 is also 2. So because 2 equals 2, you know that 9 was the correct answer. We're looking at additional properties of proportions. What are some other ways that you can set up a proportion? We have set up these proportions, or these proportions have been set up for us, really. Could they have moved the numbers around, and could we have still have gotten 12? If the two ratios are equal, then their reciprocals are also equal. A reciprocal is when you take the fraction and flip it upside down. So an example of that is if you have 6 divided by 2 and 9 divided by 3, those two ratios are going to be equal. A couple different ways to check. 2 goes into 6 3 times. 3 goes into 9 3 times. So 3 equals 3. You can also check a proportion by looking at cross multiplying. 18 and also 18 going the other way. But talking about the reciprocal, if you know that's true, then using the reciprocal rule, we could say 2 over 6 equals 3 over 9. That would be another correct way to write that proportion. Another way you can write the proportions is if you interchange the geometric mean of a proportion. If we do that, then we get another true proportion. So if 6 divided by 2 equals 9 divided by 3, we explained why that was a true statement. By switching the geometric mean is a number on the bottom of a fraction of the ratio and the top of another ratio. So we're going to interchange those. So 6 over 9 is going to equal, interchange these two, 2 over 3. Let's test it. When you multiply the 6 and 3, you get 18, and you multiply the 9 and 2, you still get 18. Those numbers are the same. Or you can reduce them to the same item, which is 2/3. There's another way that we could rewrite this. If we have 6 over 2 equals 9 over 3, then you could interchange it this way also. So you have 3 over 2, which equals 9 over 6. Again, when you test that, you cross multiply, and you're going to get the same value on both sides. The last property is in a proportion if you add the value of each ratio's denominator to its numerator. A denominator is the number on bottom. So take that number and add it to the number on top. This will give you another true proportion. So if 6 over 2 equals 9 over 3, then if you take the denominator and add it to the numerator, 6 plus 2 divided by 2, that should still equal, take the denominator and add it to the numerator, we can't reduce the 2's, you can't reduce the 3's, but if you say 8 divided by 2, that makes 4. 9 and 3 is 12 divided by 3 is also 4. So the two fractions are still equal to each other. On the next page, we're going to look for 4 true proportions that we can rewrite the one that was provided. In this section, they provide the proportions for us. In future sections, you're going to have to write your own proportion. We'll discuss theorems that give you the properties that allow you to write them, but it's more difficult that way. You've got to write your own correctly. Therefore, let's make some sense of working with these proportions. So one of the properties that we've talked about is talking about reciprocals. So if we start out with the one that they give us, the reciprocal of that would be to take the number on bottom and bring it to the top. And switch that with the top. Switch the bottom with the top. Turn the fraction upside down. So that should be another true proportion. The geometric mean. The geometric mean, remember, is when you switch or interchange the denominator and the numerator of two different ratios. So I'll keep the AC on top. I'll keep the EF on bottom. Now I'm going to switch the other two. I'm going to put the BC down here and put the DF on top. That would be another true proportion. One way you're pretty confident that that's true is we're going to multiply, cross multiply just like we would have. And when you cross multiply, even if they're in a different order, you're going to multiply the same numbers. The other geometric mean that you could multiply, or at least switch the numbers for, would be to put the EF on top on that side and the AC on bottom for that side. We'll keep the DF where it's at, and we'll keep the BC where it's at. That's another geometric mean. Now we're going to add to the numerator. That's when we took the AC and added the DF to it. And when we took the BC and we added the EF to it. Remember, you cannot reduce anything. You would add the top two numbers and then either cross multiply or just divide that number into the top value. You can't reduce if there's a plus or a minus in between values. Now we're going to solve. We could use any of those four we just came up with, or we could use the original. I would suggest to just use the original proportion that they gave us. So AC, looking back at the picture, AC gives us 12, DF is 18, BC is 9, EF is X. So we're going to cross multiply to get 12X and 162. When we divide by 12, 12 goes into 16 one time with 4 left over, so 42. 12 goes into 42, not evenly. It goes into there 3 times with how many left over? It should go in there with 6 left over. So that's why it's 0.5. 13.5 would be the value of the X number. The last example we have, we're going to take the proportion they give us and we're going to find the value of JH. Looking at our diagram, JH is X. But if we're solving for JH, JH is not part of our proportion. You might write a different proportion. That would be great. But I think we can still work this out. So we can look at this and we can say that JL, what's the length of JL? X is all the way down. 2 is the very bottom. So JL is the whole thing, not including the 2. So it's X minus 2. LH is 2. JK is 15. And KG is 5. Remember, you cannot reduce the 2's out. Because of the minus sign, you can't reduce those. So we're going to cross multiply to get 5 times X minus 2 and 2 times 15. Add the 10 across and divide by the 5. That's going to give us 8. So X is a value of 8. Looking back at the picture, JH is that whole amount. JH is X. So JH is going to equal the 8. JL is just a portion of that. So if the whole thing was X and part of X was 2, the leftover is JL. JL equals 8 minus 2. JL equals 6. And then to finish up, KL is 12. GH is our unknown. JK is 15. And JG is 15 plus 5. Again, you cannot reduce the 15s. So I have 12 and GH. I have 15 and I have 20. You could reduce the 15 and 20 now. 5 goes into 15 3 times. 5 goes into 20 4 times. 3/4. That would be fine. But most likely, most of you will keep them just as they are. You'll cross multiply. So you're going to get 24 when you say 2 times 12. Then you have the 0. So 240. 15 times GH. Now we're going to divide by the 15 to say that GH. Now GH goes into 24 just one time with 9 left over. So 90. 15 goes into 90. 90. It goes into there 6 times. So now we know that GH equals 16.